Hey guys, I hope you are having a good day. Our today's topic is triangles. In this video, we are going to study angle side angle congruence rule, which is also known as ASA congruence rule, which says two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of the other triangle. So, two triangles are said to be congruent triangles by ASA congruence rule if two angles and the side included between those angles of one triangle are equal to the two angles and the included side of the other triangle. Let us prove this theorem now. So, we are given two triangles, triangle ABC and triangle DEF. In these triangles, angle B is equal to angle E and angle C is equal to angle F and BC is equal to EF. We need to prove that triangle ABC is congruent to triangle DEF. For proving the congruence of the two triangles, see the three cases. So, the first case is let AB is equal to DE. So, we are assuming that side AB of triangle ABC is equal to side DE of triangle DEF. Now, what do you observe? You may observe that AB is equal to DE because we have assumed this. Angle B is equal to angle E, which is already given to us. BC is equal to EF, which is also given to us. So, we can say that triangle ABC is congruent to triangle DEF by side angle side congruence rule, as we have two sides and one angle which is included between those sides. So we can say that these two triangles are congruent by side angle side congruence rule. Now see the case number 2. Now let if possible AB is greater than DE. So we are taking a point P on AB such that PB is equal to DE. Now we will consider triangle PBC and triangle DEF. So we are assuming that P is a point on side AB because AB is greater than DE such that PB will be equal to DE. Now we are considering triangle PBC and triangle DEF. So this is triangle PBC. So in these two triangles PBC and DEF, we can see that side PB is equal to DE because we have assumed this, and by construction these two sides are equal. Angle B is equal to angle E, which is given to us, and BC is equal to EF, which is also given to us. So we can say that triangle PBC is congruent to triangle DEF by side angle side congruence rule, as we have two sides and one angle which is included between these sides. So these two triangles are congruent by side angle side axiom of congruence. Since the triangles are congruent, their corresponding parts will be equal. So we can say that angle PCB, this angle will be equal to angle DFE. So these two angles will be equal, angle PCB and angle DFE. But we are given that angle ACB, this whole angle is equal to angle DEF. So we are given that ACB is equal to DFE and we have proved that PCB is equal to DFE. So angle ACB is equal to angle PCB. This is only possible when these two angles are equal to each other, as we are given this angle is equal to this angle and we have proved that this angle is equal to this angle. So this case is only possible when these two angles are equal to each other. So is this possible? This is possible only if P coincides with A. This will be only possible when point P will coincide with point A, or BA is equal to DE. So triangle ABC, this whole triangle, is congruent to triangle DEF by side angle side congruence rule because we have two pair of sides and one pair of angle which is included between those sides. So we can say that these two triangles are congruent to each other. Now let us see case 3. If AB is smaller than DE, we can choose a point M on DE such that ME is equal to AB and repeating the arguments as given in case 2. So now we are considering these two triangles and we can conclude that AB is equal to DE. So triangle ABC is congruent to triangle MEF. So this triangle MEF is congruent to triangle ABC because we are taking M as a point on DE such that ME is equal to AB. Then we are considering triangle ABC and triangle MEF. So these two triangles will be congruent to each other and we are given that angle C is equal to angle F, and we are proving that by CPCT angle MFE will be equal to angle C of triangle ABC. So this is only possible when these two angles are equal to each other. So we can prove this by the arguments which we have proved in case 2. So now suppose now in two triangles, two pairs and angles and one pair of corresponding sides are equal, but the side is not included between the corresponding equal pair of angles. Now we are supposing that in these two triangles, two pairs of angle and one pair of corresponding side are equal, but the side is not included between the corresponding pairs of angles. Suppose angle B is equal to angle E, angle C is equal to angle F, and AB is equal to DE. So these two pairs of angles are equal to each other and these sides are equal to each other, but these sides are not included between those angles. So are these triangles still congruent? You will observe that they are congruent. Can you reason out why? So you know that the sum of three angles of a triangle is 180 degree. So if two pairs of angles are equal, the third pair is also equal, as the third pair will be equal to 180 degree minus sum of equal angles, as the sum of all the angles in a triangle is equal to 180 degree. So if two angles are equal to each other, then the third angle will be equal to 180 minus sum of these two angles. So all the three angles will be equal to each other. So we can say that these two triangles will be congruent to each other if the side is not included between the angles. So two triangles are congruent if any two pair of angles and one pair of corresponding side are equal. We may call it as AAS congruence rule, which is known as angle side congruence rule, because we have two pairs of angles and one pair of side which are equal to each other. Now we are performing an activity. So we are drawing three triangles with angles 40 degree, 50 degree and 90 degree. Now how many such triangles can you draw? So these are some of the triangles which we have drawn with the angles 40 degree, 50 degree and 90 degree. So how many triangles can you draw with these angles? So in fact, you can draw as many triangles as you want with different lengths of sides. So we can draw infinite number of triangles by taking different lengths of the sides and taking angles as 40 degree, 50 degree and 90 degree. Observe that the triangles may or may not be congruent to each other. So equality of three angles is not sufficient for congruence of triangles. Therefore, for congruence of triangles, out of three equal parts, one has to be a side. So if we are given that three angles of two triangles are equal to each other, then those triangles may be or may not be congruent to each other because their lengths of the sides may differ to each other. So to prove the congruence of two triangles, out of three equal parts, one has to be a side. So it is compulsory that if we are having two pair of angles, then you should have one pair of sides of two triangles which should be equal to each other. I hope you like this video. Thank you for watching.